Good graphs are very easy to interpret and are very accurate to the data. And everything is very clearly labeled so that you can see exactly what each bar or each point on a line or each wedge in a pie graph, you can clearly see what each of them are. For instance, this bar graph, that's what this is a bar graph. You can have a lot of different types of bar graphs. You can have just single bar graphs like that. The one I have here is a multiple bar graph one where there's three different numbers associated with each month. And you can also have vertical bar graphs, which is just a different way of representing the data. The nice thing about vertical bar graphs is that you can actually show both positive and negative numbers in the graph. That's the useful about vertical bar graphs. You can kind of save some space that way. But the one I have here is for auto sales, and I have some questions to answer on it. We're looking at auto sales of some company, and you can see the blue is new cars that are sold in each one of these months. The red is new trucks, and the green is used vehicles. So looking at this graph, what month has the most new car sales, and how many were sold? So you can directly see we're looking for new car sales, that's the blue, and which one has that? Well, January has the highest blue bar, so we can say January. And how many were sold? Well, looking at this line here, it looks to be at about this point here, which in my mind, it looks about 38. It's close to, it could be 39, 37, somewhere around there is accurate. I would say 38 for me. Now, let me clean that up. How many new trucks were sold in May? New trucks is the red, so we're looking at this bar right here. And that's right above this first line. The first line is 10. And so it's right above it. It looks like it's actually 12 to me. It could be 11 though. I'm going to say 12. It looks to be 12. Okay, how many more new cars were sold than new trucks in both March and April? So how many more new cars were sold than new trucks in March and April? So March, April, new cars was here, new trucks was here. So the how many more was sold is this distance here. The red bar looks to be about 15. The blue bar looks to be directly at 30. So for March, we take the higher number, which was 30, minus the lower number, which is 15. So 15 new cars were sold over new trucks. In April, this blue bar here looks to be about, I would say 24. That seems reasonable. And the new trucks here, the red bar is definitely at 10. It's right on that line. So this distance here is going to be 24 minus 10. So in April, 24 minus 10 gives me 14. So in March we had more sales, more of a difference than in April. Okay, by what percent did February new car sales increase over new truck sales? So we're looking at February. Let me clean this up just a little bit. Looking at February here, we're looking for new car sales to increase over new truck sales. The way we do this is we find the number for each of these. So new car sales is here. That looks to be about 32. New truck sales is here. That to me looks to be like 13. It's a little bit higher than 12. I would say 13. Okay, and then to find what percent did February new car sales increase over new truck sales. So we're looking for the increase. In other words, we're looking for what's this percentage increase. Percent increase there. And we're looking for how many more percentage increase over new truck sales. So we're going to take the bigger number, which is 32. That's the increased number over the new truck sales. That's what it says here. Over the new truck sales. That's going to be on bottom. What this gives us is 2.46. That's probably fine there, 2.46. Now we want to write this as a percentage. So we're going to multiply this by 100%. That gives us 246%. In other words, the new cars sold 246% more than the new trucks sold. Now, what's the actual percent increase though? Well, we always just take a percent increase by subtracting off 100%, because think of it like this, if the new trucks, which sold 13, if the new cars sold 100% as much as the new trucks, then that means the new cars would also sell 13. So this first 100% is just the same amount. It's not the increase, right? Looking at this is the same amount in both of them. I don't know if you can see that in the purple there I'm drawing. In both of them, we have the same amount at that point. We don't care about that amount. We only care about the increase, what's above and beyond the 13. That's what this 100% here is. It's the purple part that we're just kind of removing out of both of them. I hope that makes sense. What this means is that we have 146% increase over new truck sales. It more than doubled the increase. You can see that because 13 doubled is 26. And we sold 32 cars. So it more than doubled the truck sales in February. So all I did was I took the higher number divided by the lower number and made it a percentage. And all I did after that was subtract 100% from that. That gives me the percent increase. Okay, now for which month did used vehicle sales increase the most over new truck sales? Let me clean this up a little bit. We're looking for vehicle sales increasing the most over new truck sales. In other words, let me make this fine here. This is used car sales. Here's new truck sales. That's a little too fine. We're looking at this increase right here. This increase right here. That. And it's asking for which month did used vehicle sales increase the most? Which one of these distances is the biggest? And I would say March. It could be May, but it's definitely not any of the other ones. So in March, we have about, this looks to be about 20, maybe 27, maybe 28. I'd say 27. The new trucks looks to be about 15. That's a 12 car difference. In May, we have, this looks to be about 21 to me. And this is about 11, maybe 12. That's a 10 car difference. So yeah, March is the bigger sales increase. So the answer to the question would be March. March has the biggest increase of used vehicle sales over new truck sales. So I've got a line graph here, and line graphs are a way of showing a trend. They're nice. They're pretty easy to plot, and they're nice to show trends. You can ask, what trends do you see in this thing? But the first thing you should always ask is this graph, to the best of your knowledge, accurate? And this one is not, because here we have a 1960 to 1970, 1970 to 1980, and then we have 1980 to 1985. That's only a 5-year jump. The same thing as 5-year, 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 5, 5. This last one's 4-year, but that's because they took the data in 2014 rather than 2015. So that one's always gonna be only a 4-year jump. But you can see here we have 10-year jumps there. So this is not an accurate representation of these trends in this first area, because these are all 5-year jumps. So we need to reassess our data and extrapolating some of the things out, this is what I've created here. Every jump is 5 years, except for this last jump here, but that's going to be always a part of that since it was taken in 2014 rather than 2015. That's a minor discrepancy, but now the rest of it looks a lot better. And so now we can look at this thing and actually say, what are some good trends here? And you see that it looks like from 1960 all the way on up to 1985, there was a steady increase. It was getting to be more and more renewable energy production. Then from about 1985 to about 2005, it was pretty level. There was not much increase at all. There was little blips here, but that's pretty steady. But from 2005 on up, this is a pretty big increase. You can see that this increase here is bigger than this increase here. So in a shorter period of time, right? This was about 25 years. This one was only 9 years. In a shorter period of time, this is just pretty recent. There was a much bigger change in renewable energy. So you can tell that this last 9 years is going very much faster than the first 25 years. Those are some trends you can see in this data. Okay, let me clean it up now. And let's look at some questions. What is the percentage increase from 2005 to 2014? So the percentage increase is what's the percentage, this percentage here. It's kind of like the last problem we did for the bar graph. Very similar. So from 2005, we're looking at this point right here. And that looks to be, well, it's hard to see, but it looks to be about like 6.25 maybe, something like that. 2014, this point here, that looks to be about 9.9 is halfway. That looks to be about 9.75 to me. It's about a quarter way up, or a quarter way down from a 10. Those are just estimates. You don't have to be exact when you're just trying to read off the graph. You'd have to have the data to be the exact, give you exact numbers. But what's the percentage increase? Well, last time I told you we take 9.75 divided by the smaller number. That gives us 1.56. Write this as a percentage. We get 156%. But we want to take off the same portion, which is this portion and this portion here, because we only care about this is the increase. That's why we take off 100% from this. And so we get a 56% increase. That's what this right here is, a 56% increase on 2005's numbers to get 2014. Now, if the same trend, I should say same trend, followed in the next 9 years, what would be the expected renewable energy projection in 2023? Because 9 years on top of 2014 is 2023. So we're asking if it's the exact same trend. So let me clean this up just a little bit. If it's the exact same trend, what's this point here in 2023? Well, here we're essentially saying that for this much period of time, we've increased by 9.75 minus 6.25, which is 3.5. So then if we go for the same period of time, we're going to increase the same amount. We're going to add on an additional 3.5. So 9.75 plus 3.5, that gives us 10.05, 13.05 BTUs, quadrillion BTUs. I'll just say 13.05. That's what the expected number here should be. Obviously, my drawing is off because it's too high, but that's all we're doing here is we're increasing the same amount that we ran, and this ran is 9 years. So it'd be the same thing right here. This is another 9 years. This should be an additional 3.5. Pie graphs, circle graphs or pie graphs are really great at showing a breakdown of a whole, and they excel especially at budgets. And so here I have a sample budget. We have different pieces here, and we have some questions using this thing. The first question should always be, what is the sum of each portion? Like, what's the sum of all the portions? That's what I mean there. So we're going to add up all the percentages. We get 25 plus 12 plus 10 plus 8 plus 7 plus 3 plus 5 plus 7 plus 6 plus 10 and plus 7. And if the graph is accurate, you should always get 100%. If you get anything else than 100%, then you can immediately ignore the graph because it's not correct. So you can't interpret really anything off of it. The numbers aren't right. But this one is, so we can continue. What is the largest portion of the budget, and what's the smallest? The largest is clearly the biggest wedge here. 25% is housing. The smallest, that's the smallest wedge. It's right here. It's the dark green, which looks to be personal. Okay. Now, if $3,000 was the monthly budget, and the 3,000 is being broken up into all of these percentages here, then how much went into clothing? So if $3,000 was the whole budget, is 100%, then clothing, which is this dark blue, is this 7 here. So we have 7% is how much money? Well, this is very, very easily handled as a proportion. We have $3,000, X dollars, 100%, 7%. Right? And this is the base. This is the 100% that's always in the proportion. This is the percentage, or R, and this is the part. So we have a proportion here we solve by cross multiplying and dividing. So we have 100x equals 7 times 3,000. This is just 21,000. Yeah. And divide by 100. X equals $210. So they spend $3,000, and the budget says, well, they should be spending about $210 per month on clothing. If that's accurate, I don't know, but that's what we have written here. Okay, now if $200 was spent in health, how much was spent for savings? So $200 was in health. Health is this right here, which is the 5%. How much was spent for savings? Savings is the red here. That's 12%. We don't know how much was spent in savings. We do know it was 12%. Now we have 200 over x equals 5 over 12. This is a general proportion. We can solve again by cross multiplying and dividing. 200 times 12 is 2400. 5 times x is 5x. We just divide by 5, giving us $480. So that's how much is put towards savings per month.